Hello guys, this is Samadan Kale and welcome to all my YouTube channel. So guys, as yesterday we have started a math module. Okay, so today also we will continue the math module. Okay, so before that, those who are new to my channel, so please subscribe to my channel so that you can get an update about the latest videos. And those who attend the regular classes, so please like and share so that other students also get the benefit of this Python developer. Okay, so let's start, guys. In the last lecture, we have seen import math. So already we have imported the math module. Okay, now today we will see the another functions. So first today's function, I categorize it into logarithmic and power functions. Okay, so let's give the title logarithmic and second it's capital and power functions. So let's run it and take one to sales. Okay, so today's first function, okay, power function. First we see the power function. Okay, so power function, it will return a x raised to the power y. Okay, and here is the power function. Yes, this is the power function. Power, we have to give the two arguments. So first math dot power of suppose 3 comma 2. That means we have to find 3 square, then it will give 9. Yes, so this is the power. Okay, then next one is a exponential function. It will write e raised to the power x or e raised to power y. Okay, so math dot ext, exponential of suppose 1. Okay, exponential 1. So it is 2.718. That is e raised to power 1 value, e value. Okay, if you want to find exponential e raised to 0, then it will give you 1. Okay, so e raised to the power x. So it here it will give returns x to the power y. Okay, and it will write exponential of x. Okay, now let us take another function, that is logarithmic function. Okay, so log, here guys, this is the series of log functions. Yes, these 4 functions. Okay, so first one is a log. Okay, log function. So log function writes logarithmic value with base b, any base that we have given. If the base is not mentioned, then it will computed the natural log. Okay, so let's see how it is. So math dot log 1. Yes, so it will give you 0. That means all we know, the log 1's value is 0. Okay, it will computed the base, natural base. Okay, natural logarithm, that is this is the log function. Okay, then another function log 10. Okay, log of 10. This means log 10 means log to the base 10. Okay, it will write log of any number with base 10. Okay, so we will write math dot log 10 of 2. Okay, so we will get this output 0.3010. okay, and so on. So this is the log 10, sorry, log of 2 with base 10. Another one is log 1p. Okay, what? Log 1p. Math dot log 1p of this number. Just a second. Which number we have to take? Suppose 4. Okay, we have given the 4, and let's run it. It will give you 1.6094. Okay, so what it will be, right? It will be right this one, the natural logarithm of 1 plus x with base e. Okay, what it will be, right? Log 1p of x means it will be, right, this returns the natural logarithm of 1 plus x. Okay, 1 plus x is a 4. That means it will write the log of 1 plus 4 with base e. Okay, so this is the log 1p function. Another one is log 2. Log 2 means, guys, log of any number with base 2. Okay, so math dot log 2 of suppose 35. Okay, then it will be like this. It means the base 2 logarithm of x. Okay, it is a description. Return the base 2 of logarithm of x. Okay, so these are the logarithmic and power functions. Okay, so all are covered. Next function or next type of these functions is trigonometric and angular. Okay, angular functions. First, I will give double hashtag here. This, convert this code to the markdown and run it. Okay, then so let's start. All we know the trigonometric functions: sine, cos, tan. Okay, so first we will find the sine, cos, and tan values. Okay, so where this function? So this is a cos function. Okay, this is a sine function. Where it is sine function? Yes, it is in there. So this is the sine function. Yes, this is sine. Then tan. This is the tan. Okay, so one by one we will find. So first, guys, we will define a variable. That means suppose uh, angle is measured in radians and degrees. Okay, so suppose we want to find pi by 6, sine pi by 6. Okay, pi upon 6 of this sine pi by 6. We have to find the value of sine pi by 6. Okay, so first we will convert this pi by 6. Okay, this pi by 6 into, this is in radians, so we can convert into sorry, this is in uh, radians, we can convert into degrees also. Okay, so and we can write this as it is also. So how it will be? So let's see. Okay, so first we will give the variable. Suppose this is angle, we call this as a equal to pi by 6. We have to write pi by 6. So how we will write? Math dot pi. Okay, and then upon 6. Yes, we will write in this way, and we have to find the value of sine pi. So we will write math dot sine of angle this a. Okay, now this pi by 6 is this is pi by 6 is a value of a. Okay, so we will run it. So we will get the value 0.49999. Yes, and if we give the print statement to this, and same calculate the tan and cos, okay, so of the same angle. So again print math dot cos of a, okay, and what we have to print again, print math dot tan of a, okay, tan of a, and we will run. So all these three values we get. Yes. So this is the sine, cos, and tan. Okay, guys. Now there are hyperbolic functions. Okay, sine hyperbolic, cos hyperbolic. Where it is? This is a sine hyperbolic. This is a cos hyperbolic. Okay, we can find the sine hyperbolic and cos hyperbolic values also. Okay, so if we write here itself, okay, here itself, print sine hyperbolic of a, okay, then print cos hyperbolic of a, and lastly print tan hyperbolic of a, okay, and run it. So we will get, okay, sine hyperbolic is not defined. So why it is not defined? We don't give the math dot, so we have to give the math dot to each. Okay, if we don't give, then we will get the error. Okay, now all these values are getting. Yes, sine hyperbolic, cos hyperbolic, tan hyperbolic, all we can find out. Okay, so hope all of you understood. Now guys, next function is this a cos hyperbolic, a sine hyperbolic. It means what? Okay, so we will take these functions. So a cos means, guys, arc of cosine angle, okay, and a cos means inverse hyperbolic cos. Okay, so we will write description also. If we give math dot a cos of, suppose, this number 2, okay, and run it, then math domain error, it will give you math domain error. So we have to write what we have to write. Let us check. Return the arc cosine measure in radians of x. Okay, so if we give here math dot pi, then yes, it is again error. Second, if we detailedly see, the result is between 0 and pi. Result is between 0 and pi. So we have to give here number, suppose 45. Okay, then it will also give error because, again, how to check it. Okay, we will take latter. So first check another one, another function. I got it. Okay, now check another function. Is that now special function? These are the trigonometric functions. Again, in trigonometric function, there are angular. Okay, so this is angular, na? So if we have given the degrees, that is converted into radians, and if we have given radians, that can be converted into degrees. So how we can convert it? Okay, so we can convert math dot degrees of this function math dot pi. Okay, so the pi is in radian, we have to convert into degrees. So 180 degree. Yes, Again, if you want to write this math dot degrees of this function, uh, 3 star 3 star math dot pi upon 2 means 3 pi by 2. Okay, so it is a 270. Okay, so it is a 270. Now it is a 3 pi by 2. Okay guys, so this is the degree. Now we will take the next function, radian function. Math dot radians of, suppose radians. What is radians? Radians. So radians. It is radians. How to radians? 34. 45. This is radians of 45, and this 0.785398, and so on. Okay, so we can convert this 45 into radians. Okay, so this is in degrees, we converted it into radians. So these are the trigonometric and angular functions. Now we are going some special functions. Okay, now to the heading special functions. Yes, convert it code to markdown and run it. Okay, now here we see the spatial functions, that is a cos hyperbolic, a sine, and so on. Okay, so first we will see a cos. Okay, so math dot a cos of 0.2. Okay, so if we run this, we will get this value. A cos means the arc of cosine. Okay, arc of cosine. Now, so here this value x is 0.2. Instead of 0.2, we can put the values from -1 to 1. So if we put -1, run it, it will give the value. If we substitute 1, then it will give the value. But if we write 1.1, then we will get the math domain error. Okay, so this is the thing that we have to remember. So this function can takes only -1 to 1 values, a cos function, and it will it means the, what it means, it means the arc of cosine. Okay, so it returns the arc of cosine measured in radians of x. Copy it, and here, so this is the a cos. Now another function, second function, that is a cos hyperbolic. Okay, so math dot a cos hyperbolic of, suppose we write 2, then what we get, we will get this one. Okay, so again, if we check its description, it will return the inverse hyperbolic cosine of x. Okay, what it will be written, it will be written the inverse hyperbolic cosine. So in trigonometric functions, we see the hyperbolic cosine. Here we see the inverse hyperbolic cosine, that is a cos hyperbolic. Okay, now a sine. Okay, next one is, that is the math dot a sine of. Now here we substitute 2, then what we will get, we will get again a math domain error. Yes, if we write -1, then what we will get, we will get the value. If we write the 1, okay, then we will also get the value. Yes, But if we write 1.1, then what we will get? We will get again math domain error. Okay. So for arc sine and arc cos, we have to give these values of x in between the range -1 to 1. Okay. Range of x is in -1 to 1. Okay. So we have to give the description of this. Okay. So a sine of 1, run it here. Okay. Run it and copy it once again. Yes. So shift tab. So it will return the arc sine measured in radians of x. Okay. And paste it here. Yes. V, and what is the range of x? X is in -1 to 1. Okay. Now this is a sine. Now a sine hyperbolic. Okay, we will see a sine hyperbolic. So that is math dot a sine hyperbolic of this angle suppose 34. Okay. So what it will be write? It will write the inverse hyperbolic of sine. Okay. So it will write the inverse hyperbolic of sine. Okay. Return the inverse hyperbolic of sine. Yes. This is the thing. Now, what we have to see? We all seen a cos, a sine hyperbolic. Now a tan and a tan 2. Okay. A tan and a tan hyperbolic same as that of cos, a cos and a sine. Okay. Now we will see a tan 2. Okay. A tan 2. So it means we have to give here two arguments. Okay. So math dot a tan 2, we have to give two arguments y and x. Okay. So first we will give 3 and then 4. Okay. What it will be right? It will be right a tan of y upon x. Okay. What it will be right? A tan y upon x. Okay. Arc of tan y upon x. We run this, it will be the output 0.6435. Okay. So what it will be right? It write the arc of tangent measured in radians of y upon x. So first is y, 3 is y and 4 is x. Okay. So give the hashtag here. Yes. So this is the thing. Now which is the next function expm1. Okay. expm1 we will see in special function. Okay. So write just math dot expm1. Oh, now what it will be right? It will return the value of e raised to the power x minus. Okay, e raised to power x minus 1. expm1. The function will write the value of e raised to power x minus 1, where x is the number entered by us. It means e raised to power 3 minus 1. Okay, if you want to check, you can check it. Okay, this is e raised to power x minus 1. Okay, now here there is a confusion. What is confusion? So e raised to x and raised to power not x minus 1, e raised to x minus 1. Okay, so this is expm. Yes, there are so many functions again in special function. We are going to take the next function. Yes, yesterday we have seen the product function. Okay, that is a product. So which is used for list. Suppose we have a list of these numbers. Okay, 1 2 3 4 5. Okay, this is the list. We have to we are going to use the product function. So we will use math dot product. Okay, of this list L. Okay, that is iterable. Yes, and we will get the product of all these numbers, that is 120. 1 into 2 into 3 into 4 into 5, that is 120. Yes, This is a product function that yesterday we have taken, but it will not will not give us output. Okay, so for that we have to give L as a list. Yes, so this is the product. Now next one is f sum function. Where it is? This is f sum. Okay, it is same as this. Okay, just I copied this list. Is same as product function. Paste it here, and I'm going to write math dot f sum of this function L. Okay, it will write the sum of all these numbers. Okay, sum of all these numbers, that is 15. So this is the f sum function. Now we are going to see the next function, that is a gamma function. Where it is? Gamma function. Okay, so this is the gamma function. So what is gamma function? Gamma function gives the gamma value of the argument. Okay, there is a gamma function in statistics and mathematics. Okay, so if you want to find the value of gamma variable, then you the gamma method of the gamma of anything for 45, then it will give us this value. Okay, now there is another function, that is uh, L gamma. Yes, where it is? L gamma. So this is the L gamma. Yes, so what it means? Okay, so we are going to write this L gamma now. To math dot L gamma of some number x. Suppose we have given 32. Okay, and run it. So we will get the output. So what is L gamma? Okay, what is L gamma? It will return the natural log of the absolute value of gamma function. Okay, so if you want to see, you can see here natural logarithm of absolute value of the gamma function at x. Okay, so you hear the description. Yes, so this is the thing. Now the next function that we are going to take, that is uh, mod f. Okay, where it is? Mod f m. Yes, this one, mod f. Okay, so it will write the fractional part and integer part of the number x. Okay, suppose we have given this number as math dot mod f of 2.3. Okay, so it will give the fractional part and the integer part. So what is fractional part? 2.99998 means it is a 3, and 2.2 is a integer part. Okay, if you want to see the description of these, you can give the return the fractional and integer parts of the x. Okay, so you can write here. Now next function, is there anything remaining or not? Just I want to check. Yes, copy sine function. So math dot copy sine, okay, of suppose 2 comma minus 3, and run it. Then what we will get, that is minus 2. Okay, copy sign means, guys, it will write minus times x. Okay, that means it will give the second number sign to the first number and write first number. Okay, if you want to see the description, it will return a float. Okay, with the magnitude of x but the sign of y. Okay, it will give the magnitude of x but sign of y. Okay, guys, so this is the description. It means it will write 2 means x. Okay, and give the sign of second number, that is minus sign to the second number. So this minus sign goes to the 2. If you write 3 only, then it will give output 2 only. Okay, if you write minus 2, then it will give plus 2 again, because second number sign. Okay, so this is the copy sign function. Yes, so I think all functions are covered which are remaining that you can learn yourself. This is homework for you. Okay guys, so maximum number of functions are covered in this lecture. Okay, if you want this file, so I will give the link of this file also, and I will share the PDF also. Okay, so this is the thing. So guys, hope all of you understood the math module. Okay, in the next lecture we will going to see the strings in Python. Okay, so have a nice day and thank you for watching the video.